So this picture that we have here is an example of a rhombus. So the singular is rhombus, the plural is rhombi. Sometimes rhombuses is okay as the plural. Okay, so the first property that we have here is that the pairs of opposite sides are parallel. So the opposite sides are the ones that are across from each other. So in this rhombus here, the parallel sides are BC is parallel to AD because they're the ones that are across from each other. BC and AD are parallel. The other pair of parallel sides would be AB and CD. Okay, another property, part of the first one, is all of the four sides are congruent. So that means all of these sides here would have the same measure. Whatever is the measure of one side is the same all throughout. So if this is 5 for BC, all the rest will be 5. So we can go ahead and write it down here. So all four sides are equal each other. Next, for the second property, opposite angles are congruent. So the opposite angles that we have here are B and D. So B is congruent to D. So we can write it down here. So angle B is congruent to angle D because they are across from each other. We also have another congruent pair of angles. That would be angle A, they're opposite, and angle C. So we can add up another pair of congruent angle. That's angle A is congruent to angle C. Next, the other property is that adjacent angles are supplementary angle. So that means if we add BC, angle B and C, that's 180. If I add A and B, that's 180. If I add A and D, that's 180. And if I add D and C, that would be also 180. So we can write that down here. So we have four supplementary angles. So BC, CD, DA, and AB. So just add them up. They equal 180 because supplementary angles equal 180. Next property, diagonals. Remember that diagonals is a line that passes from one corner to the other corner that are opposite from each other. So we can draw one diagonal here and another diagonal across. Okay, so, and then we can name this one as E in the middle. So then diagonals are perpendicular. So perpendicular means they form 90-degree angles. So this corner here, this angle is 90, 90, 90, 90. So all four corners in the middle is 90 degrees because they're perpendicular. And they bisect each other, resulting to form four congruent triangles. So this first diagonal, this longer diagonal, was bisected. Bisected was cut into two pieces. So this this side length and this side length would be equal each other. So we can write it down here. So the first diagonal that was bisected is AC, and so AE is equal to EC. So AE is equal to EC. And then the other diagonal, the shorter one, was also bisected. Bisected means it was cut into two equal pieces. So we can go ahead and write that down here. We also have that's going to be BE is congruent to ED, the other half. So that's the third property. And the last property here is that diagonal bisect opposite angles. So what does it mean? So these opposite angles here are bisected. Bisected means it was cut in half. So this corner was cut in, this angle D was cut in half. And this is also cut in half. So we can go ahead and say that that's going to be angle BDA. BDA is this corner. This is BDA. And that is congruent to the other side, BDC. And then, so these two are congruent. And then these two are also congruent. This two right here was cut into two pieces. So that would be, another set would be ACB is congruent to angle ACD. The other partner for this BDA is the one across, so that would be DBA. So angle DBA is congruent to angle DBC. And then these two are also congruent. It was cut in half. So it cut into two equal pieces. So that would be angle CAB is congruent to angle CAD. So these are the properties of rhombi. Now let's have some examples to better see sample problems that uses these properties of a rhombus. Okay, so let's go over this example here. So we're given this rhombus here, and the property we're given, the AB is 2x plus 4 and BC is 5x minus 5. We are asked to determine what's the x, what's the measure of BC, AB, AD, and CD. Since the property, one of the properties of rhombus is that all four sides are congruent, so these two are equal each other. So we can go ahead and solve for x by putting them equal to each other. So that's 5x minus 5 equals 2x plus 4. And then we go ahead and do the math here. So the value of x here is 3. So what I did was I just equal them to each other since all the sides are equal. And so we get x is 3. Now we wanted to determine the measure for BC. So BC is right here. We know that x is 3, so we plug it in. So that is 5 times 3 minus 5. So 5 times 3 is 15. 15 minus 5 is what? 10. So the measure for BC is 10. What is expected for all the rest of the sides? It would also be 10 because they're all equal. So let's plug it in here. So that is 2 times plus 4. 2 times 3 is 6. 6 plus 4 is 10. So this is also 10. Since this is a rhombus, all the rest will be 10. So all sides are congruent. So AD is 10 and CD is also 10. Now let's have another example. So let's go over this example. It says opposite angles are congruent. So the ones that are across from each other. So angle H is also 47 because they're opposite. So I write it out. So this one right here is 47. Our task is to figure out what is T and K. We already have H. If we look at these two angles here, angle W and angle T, they are adjacent or they are consecutive. So the other term for adjacent is consecutive. Consecutive means they're next to each other. So the other word for consecutive is adjacent, or adjacent and consecutive, they mean the same thing. So it says that if they're adjacent angles, they are supplementary angles. So how should we set up our equation? That would be, angle T plus angle W equals 180 because they're supplementary angle. So what happens next after this? So this would come out, angle T is missing. Plus angle W is 47 equals 180. So then we're looking for angle T. So we're going to subtract 47 from both sides. So that's minus 47 minus 47. So we are left with just angle T is equal to 133. So the measure for angle T is 133. Now, what is the measure of angle K? They're across from each other. This is also 133. Because whenever they are across from each other, they're equal. So once we already have angle T, 133, across from it, angle K should also be 133. And that's 47 and 47. Because opposite angles are congruent. So we can write it down here, 133 and then 133. Another way to check if we did the math right is that the sum of all the interior angles of every quadrilateral, including a rhombus, is 360. So let's try adding everything out, and then let's see if it's 360. So 133 plus 47 plus 133 plus 47. The answer is 360 because the sum for every quadrilateral, including a rhombus, is 360 degrees. Now let's have another example. Okay, so let's go over this example here. We are given this rhombus, and then we have a diagonal EAC and BD. It says that our AE is x plus 12, so we can write that down here. So AE is x plus 12. Well, EC is 3x minus 8. So the other diagonal is 3x minus 8. How do we solve for x? We remember that diagonals are perpendicular and they bisect each other. So we can go ahead and say that these two are equal each other. So that would be 3x minus 8 equals x plus 12. So let's show the work on this. So our x here is 10. Now we're supposed to find for AE. So since AE is equal to x plus 12, so plug in the 10. So 10 plus 12 is 22. So our AE is 22. Now our EC is 3x. So 3 times 10 is 30. 30 minus 8, because x was 10. So 3 times 10 is 30. 30 minus 8 is 22. So both of these are 22 and 22. Now we are looking for angle BEC. So we are looking for BEC. So this corner. Remember that diagonals bisect each other. So, diagonals are perpendicular. So what do you mean by perpendicular? What's the measure? 90 degrees. So BEC is 90. What about AED? So AED. So the one across is also, all these corners are 90. So that is also 90 degrees. Let's have another example. Okay, so let's go over this example here. So we're given this rhombus here and we're supposed to find for the rest of the measures here. So let's start by looking at the rhombus here. We got 130. So this is 130. We're looking for angle D. So these two are opposite. Remember, opposite angles are congruent. So our angle D is also 130 degrees. So this is because these two are opposite. So this one right here, angle D is 130 degrees. Now, the next angle that we're looking at is angle DAB. So, DAB. So, this whole thing right here. So, what is this whole red angle? So, that is DAB. So, DAB. Now, we remember that these two angles are what? Consecutive, next to each other. So if they're consecutive or adjacent, we add them up equals what? 180. Good. So to solve for this side, we're going to add these two up equals 180. So I can go ahead and say angle A plus angle D is equal to 180. We plug it in. Angle A is missing. So angle A plus our angle D is 130 equals 180. So then we subtract 130 from both sides, minus 130. So then we are left with angle A is equal to 50. So this red corner is 50. So that's 50 right there, the whole thing. So we can write down angle DAB is 50 degrees. Okay, now we're asked for DCB. That's DCB. So DCB is across from A. So what is the measure for the other corner? If that is 50, what's the other side? 50. So this one is also 50. Okay? Because remember, if they're across from each other, they are equal. Across from each other, they are equal. And we solved it. Angle A is 50. So angle C is 50. Now, we have another angle here. Angle BAC. So BAC. This corner right here. If the whole thing is 50, what is this corner? Remember that diagonals bisect opposite angles. That means this was cut in half or cut into two pieces. So if the whole thing was 50, so this was 25 and this one was 25. The whole thing was 50. Okay? So BAC is 25. DAC is also 25. The whole thing was again 50. The whole thing again was 50. Cut half and half, 25 and 25. So DCA is also 25 and BCA is also 25. Let's have another example. Okay, so let's go over this example here. So we are supposed to solve for angle E. So let's start with angle E first. This is 110 for angle G. Across from it, this is what? 110. Because remember, if they're across from each other, they're equal. So angle E is 110. Now we're looking for angle GHF. So that's G, H, and F. So this corner, what is this? That's 5x minus 10. So we need to figure out what the x is. So we need to figure out what is our x here. We remember that this diagonal here cuts this angle into two pieces. If this first corner here is 5x plus 10, what is the other corner here? 5x plus 10. They're the same thing because it was just cut it, they're equal. So the other side is also 5x plus 10. So they are the same. So that means if this was 70, this is also 70. If this is 30, this is also 30. What it's trying to say is that these two angles here are equal. It was cut into two equal pieces. So we also remember that these two angles here are consecutive. They are next to each other. So if they are next to each other, they're adjacent, they're consecutive, they're equal to what? What are they equal to if they're consecutive? 180. So that means we're gonna add everything up to 180. So this is how we set it up. 100, that's angle G plus angle H equals 180. Our angle G is 110. Our angle H is, there's two of them, 5x plus 10 plus 5x plus 10, because there's two 5x plus 10. And everything else is equal to 180. Next, we combine like terms. So we have 5x and 5x. So that is 10x. And then we combine the constants. 110 plus 10 is 120. Plus 10 is 130. So that is plus 130 equals 180. We wanted x by itself, so minus 130 minus 130. So we are left with 10x equals 180 minus 130 is 50. So then divide both sides by 10 divided by 10. So the x is 5. So our x is 5. So from here, we can go ahead and determine GHF. We know that GHF, so angle GHF has an equation 5x plus 10. So we're looking for GHF. So GHF, so this one, that's equal to 5x plus 10. So we plug it in. So that is 5 times plus 10. Our x was 5, so I put it in here. So that's 5 right there. So 5 times 5 is 25. 25 plus 10 is 35. So GHF is 35. What about EHF? EHF, so this is also 35. So that means this side, this corner is 35, and this other corner is also 35. Both are 35. Next, EHG. So EHG, the whole thing is what? 70. Because 35 and 35, that is 70. Next, EFG. So that means this whole thing here. EFG. If this other side is 70, what is this? This is also 70 because they are congruent. They're opposite. So EFG is 70. What about EFH? Half and half is 35. So this is also 35 and this is 35. So EFH is 35. So that wraps up the properties of rhombus.